Good day, everyone. This is again Mathematics. I thank you for being there. Thank you for the comments so far. Thank you for the subscription. Thank you for the followership. Thank you for the encouragement. Now, today we want to look at differentiation rules. We have the first one as chain rule. We have product rule. We have quotient rule. Now let's look at chain rule. There's a question here: differentiate y is equals 3s squared plus 5, all in bracket, raised to power 4 with respect to x. Now the question is, when do I use chain rule? What is even chain rule? How do I use it? Very simple. That's the question many people have been asking me to explain. Now, if you look at this question, you will see what is in the bracket is a quadratic function because x is carrying a power of 2. So whatever that is in the bracket is a quadratic function. Now, assuming I have 3s squared plus 5 all raised to power 2, this one will be easier to expand. 3s squared plus 5 into 3s squared plus 5. There's no need going through this chain rule process. I can just do this elementary sign. This times this times this one times this one times that. You understand? But now it is to the power 4. For you to open it into 1, 2, another 1, 3, another 1, 4, the expansion will be complex. So what we do, we just use the shorter way out, which is what? Your chain rule. When do you apply chain rule? When a function is carrying another function. You understand? Or you have another function in another function. How do I mean? Power itself, power is a function. Quadratic is a function. So I'm having a function on top of another function. Do you understand? I'm having a function on top of another function. So in this situation, the best way to quickly get to my result, which is my answer, is to use chain rule. It will get to a point where I will chain the result I've gotten from one, I will chain it with the result I've gotten from the other so that I can reach where I'm going to. So look at it. Solution, I will say, okay, I'll tell you can choose any other letter aside of these two that I use here. Let me say b. Let b equals what is in the bracket, 3s squared plus 5. This is a different function, quadratic function. So I will differentiate this b with respect to x because these are these two unknown present here. I will say db over dx will give me, remember these two will come behind, 2 times this 3 x raised to power 2, you subtract 1 from it, plus if you differentiate a constant which is 5, it's going to give you 0. Some may want to ask, how is this one a constant? Any number that does not carry an alphabet or a variable is called a constant. This is not a constant because it's carrying a number and a variable. This is only a number, there is no variable attached to it, therefore it is what? A constant. So the rule of differentiation is that when you differentiate a constant, you must get what? 0. So if we go further, 2 times 3 is 6, x, 2 minus 1 is what? 1. Now, I will go back to the question, I will rewrite it as y is equals, I will not write 3s squared plus 5 because I've already said let b represent it. So I'll write, instead of this, I'll put b raised to the power of what? 4. Did you see that? So I'll now differentiate. These are the two unknowns here. I'll say dy over db will give me 4. This 4 will come behind 4 times b raised to power 4. You subtract 1 from it, and that will give you 4b raised to power 3. Now, when you have reached this point, it is time to change them. How? Don't forget, I'll bring this one and this one, I'll bring them together by multiplying them. I'll say dB, which is coming from here, over dx. The chaining now is times, I'm chaining them, dy over dB, which is this one. I have to chain these two. And after chaining them, check. dB cancels dB. What is remaining? Dy over dx. Is it not so? So that is why here we have dy over dx. And because by the time they cancel out, you don't need to strike them, just leave them like that. By the time they cancel out, you'll be having dy dx left. That's why you see in this place dy over dx. Now, I'll bring them together. What's my dB dx? Is 6x raised to power 1 times, which is the same thing as 6x, times dy dB is 4b raised to power 3. Now, you can multiply 6 times 4. I'll be having 24, then x times b raised to power 3. This b raised to power 3. Then I'll return, I now conclude by saying dy dx is equals this 24x, then open my bracket, I'll bring my b back. I said b is 3s squared plus 5. Close my bracket, raised to the power of 3. This is my final answer.